When wild salmon smolts migrate from our rivers into the sea, they encounter many other forms of marine life not found in the rivers where they spawn. Among these natural marine life forms is the sea louse. While the name may not be very pretty, the sea louse is part of the natural marine ecosystem, and it lives on the skin of the salmon. It is perfectly normal for salmon and other fish to have sea lice on their skin while they are at sea. However, they disappear once the salmon swim back up the river, because sea lice, as the name suggests, cannot live in fresh water. Salmon and sea lice have coexisted for millions of years. However, while mature salmon can accommodate sea lice without any ill effects, the younger juvenile salmon, or smolts, can, under certain circumstances, be overburdened. Over the past 30 years, the numbers of salmon returning to our rivers have declined quite significantly. Up until the 1980s, the numbers returning were between 20 to 25%. Today, that number has fallen alarmingly, to the extent that out of every 100 salmon leaving, only about 5 come back. This has worried fishery scientists who have been searching for the cause of this decline. Some researchers put forward the theory that sea lice infestation of the smolts could be a major factor in the decline in marine survival. It was also claimed that this was due to an increase in sea lice populations at river mouths due to salmon farming. If it were found to be true, this would have serious implications for the survival of the Atlantic salmon as a wild species. As the state agency responsible for marine science and research in Ireland, the Marine Institute decided to test out the theory. It carried out a very long and very large series of experiments to test the impact of the sea lice on the young salmon. It involved 350,000 salmon smolts, released into 8 different rivers over a 9-year period. One half of the fish were treated with a veterinary medicine, which protected them from sea lice for the first 6 weeks at sea, while the other half were not. The numbers of salmon in each batch that returned to the rivers were noted and counted, and then the batches were compared to see if the protected fish did better than the others. The results were very interesting. There was a difference, but it was very small. On average, across all the experiments, it amounted to just 1%. In other words, of every 100 fish leaving our rivers, just 1 does not return because of sea lice. The other 94 which do not return are lost at sea for other reasons. An almost identical series of experiments, carried out in Norway at around the same time, came up with very similar findings. Also, both experimental groups, treated and untreated, had a similar overall rate of loss as the wild stocks in the rivers, showing that they too were experiencing the same conditions. Interestingly, the results were the same whether the rivers used to carry out the experiments had salmon farms at their mouths or not. Even on the occasion when those farms reported a high incidence of lice, the results were the same, indicating that there was no connection between the salmon farms and the survival pattern of the smolts at sea. These 2 large-scale independent studies clearly tell us that the reduction in the numbers of salmon returning to our rivers over the past 30 years is not the result of sea lice, and therefore can have little or nothing to do with salmon farming activity. Based on this work, the Marine Institute of Ireland have been able to conclude that the sea lice are a minor and irregular component of the mortality of wild salmon. They have also stated that the effect of sea lice is not big enough to significantly influence the future of the wild stocks of Irish salmon. Not everybody agrees with this analysis. Another group of scientists analysed the Marine Institute's data. Using a different type of statistical analysis, they came to the conclusion that the Marine Institute group had marginally underestimated the effect of sea lice. They calculated that it was closer to 2%. The important point is that whether it's 1% or 2%, it still remains a minor component of overall marine mortality. However, these scientists went a step further and tried to transfer this 2% over to make a comparison with the very small number of fish actually returning to the rivers. They reasoned if the influence of sea lice was somehow eliminated, then instead of 4 fish returning to the river, 6 would come back. They then suggested that this represented a 30% influence on salmon survival attributable to sea lice. This has caused a lot of confusion. The argument has been presented simplistically in the media, that the Marine Institutes say that sea lice cause 1% mortality, and this other group of scientists say sea lice actually cause 30% mortality. People don't know who to believe. In fact, if one compares like with like, both groups hardly differ at all. They both agree that the influence is small, but by applying the effect to very low numbers of fish returning, one group have grossly exaggerated the position. Let's look at it from another perspective. Imagine a shopkeeper places 100 apples on display outside his shop. He notices that 2 have worms. Later, when he returns to inspect the display, he finds that 93 have been stolen by passers-by. Yet, when asked how sales are, he says, "Terrible. Those worms are ruining my business." You could say, a classic case of misplaced blame. This is clearly a ridiculous way of attributing blame. In this case, worms, much like the sea lice, are responsible for only a minor reduction in the stock levels. He should have blamed the thieves for most of the troubles, not the worms. It's not a valid scientific comparison to transfer the small influence caused by the sea lice on the salmon going out to sea, and then apply this to the very small numbers returning. Plainly, we must now look elsewhere for the explanations for the steep decline in our salmon stocks. In particular, we should look to the international high seas trawler fleets, which routinely fish in the Atlantic salmon's feeding grounds. Evidence from recent studies suggests that activity on their part may well be a serious cause of the stock depletion. We also know that natural predators of the salmon, such as our native grey and common seals, have also greatly increased their numbers in recent years. The increase in the seal populations has undoubtedly put extra pressure on the salmon's survival prospects. We do not yet know the exact answers to the questions, but it is clear that the focus of scientific research must now look beyond salmon farming if the cause of this mystery is to be uncovered, and the trend of decreased wild salmon survival is to be reversed. The time has come to move beyond argument and find out what is really devastating our treasured wild salmon stock.